you want to help the New York Perlmongers, you email us. We're always looking for people who can help coordinate the organization type stuff. We have people who work assigned a month, and basically you find a venue, you find a speaker. If you don't find a venue, it's your apartment. If you don't find a speaker, it's you. It really motivates you when you have a bonus on that. Next week we're doing October is my month, I think. And we are doing something a little special. We are having a roundtable discussion. It's a week from tonight. Open forum roundtable, kind of just like this, except instead of me standing up here and talking to you, we're all going to be talking to each other. We're going to have changing. There's going to be different people in the crowd to talk. It's very open. Bring your questions, bring your answers, bring your thoughts, bring your questions, concerns, bring your calls for help to deal with modules, bring your calls for help to deal with how to shave your cat or yak or whatever the case may be. The nice thing about that is it kind of coincides with DancerConf, which the first annual DancerConf is this upcoming week, by the way. And so we are getting a couple of people who we do not usually get because they live outside of the tri-state area. And that includes Sawyer X, who is the maintainer for Dancer 2, and Peter Rabbitson, who is the maintainer for Duke's class, I believe. And SQL Abstract, and they're both really great guys, great speakers, have lots of great thoughts, opinionated in all the right ways, and some of the wrong ones too. So I hope you come out, have a little fun, bring your thoughts, and kind of have a collective discussion where we can help solve each other's problems. And that's going to be next week. You have to RSVP online. That's at the Empire State Building, and they are not as friendly with security, kind of last-minute RSVP things. You have to do that ahead of time. I'll be sending an announcement a day before saying last chance. Do it then if you can't do it tonight. All right? Thank you, guys. I'm going to cede the floor to Rudy, who is hosting for this evening.
And back to the next announcements.
Yes, this dovetails on Jordan's announcement. On 4 weeks from tonight, I believe we will be having a meetup at Media Math, where I work, the first one that we've had there in about a year's time. And we're looking for possibly one 10-minute talk or one 20-minute talk to round out the schedule for that evening. And so if you have a presentation that you'd like to give, I definitely urge you to contact me about it. One of the things that we've always said about the Perl technical meetings in New York City is that this is a place where you not only learn to code, you learn to talk about code. And we've always had a tradition of being supportive of people who are giving their first presentations about some sort of open source project. So that's something to bear in mind for this event. Well, for the event, which is 4 weeks from tonight, but also, of course, just over the course of the fall, winter, and spring, we hope to have an average of one technical meetup per month, and so we have plenty of opportunities for people to give their first or their second talk. You don't have to be a world famous speaker to speak at your Perlmongers. Part of the reason why we're scheduling that meeting for October 28th rather than sometime in November is that in the second week of November, November 8th and 9th, we have the Pittsburgh Perl Workshop, the 6th or 7th edition of that event. And if you are attending, and even we certainly encourage you to attend the Pittsburgh Perl Workshop. It's always a fun event. And if you should be giving a talk at that workshop, there would be a particular reason to try to give a talk at the Perlmongers on October 28th, but because it could serve as a dry run, which is, a matter of fact, my motivation for speaking on October 28th. So the roundtable meetup with special guests Reva Sushi and Slayer X next week, 4 weeks, a meetup at Media Math. We'll have details to be posted. And second weekend in November, Pittsburgh Perl Workshop.
And I've got, I guess, one announcement here, which is that we've got some O'Reilly swag-ish stuff, some sort of pamphlets or something like that, and stickers. If anybody wants them, they're over here. And we've got high performance browser networking. Does anybody, I guess if we have more than one person wanting this, we can do a raffle or a trivia or something. Rock, paper, there we go. We'll do rock, paper, scissors if anybody, if more than one person wants it, but otherwise, we've got one taker. Any other takers?
Rock, paper, scissors.
All right, so.
Okay.
Scissors.
You could have changed.
There you go. And for the main event.
I'll pay you for it.
Okay. I guess this is the only thing he knows.
Always.
Oh, that was cold.
Hi everybody, I'm Sam Kaufman, I'm the CTO here at SocialFlow. Today I wanted to present just about the lessons we've learned and the stuff we've built in order to do DevOps in the cloud, specifically with Perl. So what SocialFlow is, SocialFlow is a social media platform. We help magazines, brands, retailers publish onto social networks and then get their analytics off of social networks. We currently work with Twitter, Facebook, Google+, LinkedIn, just added Instagram support. So yeah, we early on like version 2 of the software, decided to go with like a web services sort of microservice infrastructure, which is very cool in that it's less monolithic than having just like one giant application. And it's a huge pain in the ass in that when you have 100 services and one of them dies, you gotta find it, restart it, fix it. So yeah, it's more points of failure, but it's also can be more resilient if coded properly. And pretty much anything nowadays that you will see in terms of like cloud deployment is reliant on this sort of like having multiple redundant services and splitting up everything into smaller services. So just quickly, what is considered DevOps? It's pretty buzzwordy, and like people just started using it the past, I don't know, Wikipedia dated it to some like Belgian conference of developers. But this diagram from Wikipedia sort of illustrates what I think of it as. It's the intersection of development, operations, and QA, where development is in charge of building new software and breaking things. QA is in charge of finding things that are broken and telling development to fix it, and also trying to keep broken things from going to production. And operations traditionally keeps the operating system happy, keeps the hardware happy. If you're on hardware, if you're on Amazon, which is in our case, deploys all the various crazy stuff that you have to do to keep Amazon happy. Figure out what size instance you have, figure out what regions to deploy in, leverage the load balancers. So DevOps is sort of programming for the intersection of that. Generally, things you'll hear around DevOps is like people will use like Puppet or Chef to manage what software their systems have, where you can specify like, okay, everything gets Postgres if it's like in a Postgres group. That's not as much what I was going to talk about. I was going to talk about more from the applications deployment setup. We actually experimented with Puppet also, but that's a whole other talk about the hell we've gone through. So now we're actually more in the scripted ourselves territory, and it's been working pretty well. So yeah, brief history of applications deployment at SocialFlow. In the beginning, there really were no rules. You would typically, this would be a typical case. You guys see that like L? Yeah. I see. I think I can alt click.
Three sections.
This is pretty nifty. Yeah. No. That would be cool if it worked. But let's see. Alt click. No, that ain't that. Let's see if plus works. Yeah, good old plus. Might be a little easier to read.
Better.
Better. Basically, what's being illustrated here is the general deployment and applications deployment process would be SSH to one of our machines, make a directory, get it running, and then hopefully you can make your changes into version control and tell other people who are going to have to change it, where it is, what it does, and how to start it and stop it. Some of my favorites here are the old Redis server, redis.conf, which will show up in your process tree. So when you're asking, where is redis.conf, that's always a fun game, trying to figure out what config it's actually running, because it'll take a relative path really happily. So you have to end up like digging in the proc directory to see what the working directory was when the command was executed, or even more fun to deal with Redis server dash, where someone SSH'd in, catted the config, and then started Redis server with standard in. So that's even more fun to figure out what actual active config in play is. Let's see. So the demonizing mechanisms, which is pretty important, obviously, if you're going to go with a setup that relies on everything being a daemon, is we tried run it. With some success, it does stuff, but it's incredibly hard to get right. I found it's great because it's just shell script. It's bad because it's just shell script. It also wants to be process ID 1, which is crazy, and will, it adds pretty much like a huge dependency if you want to use it. Everything needs to be sort of run-in based. It has a really nice feature that when something dies, it'll restart it. I'm sure that's also configurable. It's probably like what signals you send it. But if you say start something that demonizes, you will have 1,000 of them very quickly. And it's not very smart about that, and does not care how long it's been up for. I'm sure people have built tooling around it to make that work better, but we sort of gave up on it. Other things, we bothered to make like an etc init thing, where that would actually start the specific daemon. That was a limiting success. It was nice when we had it, but it was also wasn't standardized, so it might have start, but it wouldn't have stop. Like, might not work half the time. Other times, people would just like write in like a daemonize option onto their script, so that you'll just start with daemonize and it'll start as a daemon. The standards in terms, so this is where it really, started being painful in terms of like, especially from an ops perspective. You get on the box, the time you're on the box is when something's wrong and you want to fix something, and then you're like, where are the logs? The logs could be nowhere. They could be gone to dev null if it's backgrounded and there's no, just like close, standard out, standard error. Could be on standard error running in somebody's screen, or tmux as the years went by, and tmux got sort of made the scene. Some people just log to TMP, open up a file, write to it. Other times they're just dumped to like doc /. So wherever you found the process, you might find the logs. The code would live either in like /opt if you're a little smarter about stuff, home if you're really lazy, ebs, which would be like a second volume, like with Amazon, they have Elastic Block Store, which is like a virtual hard disk. So we would attach one, call that EBS, attach the second one, call that EBS2, and then be like, where do I have free disk space? Let me go to there, make a directory, and of course not in fstab, so when you restart the box, it was gone. It's a find it. State files could be anywhere that you put them or nowhere. And the config, generally we found sort of committed into version control, which is not great. And then that ends up being manually edited on prod when changes need to be made. Yeah, not so great. The deploy process, yeah, I sort of covered this already. But basically, the deploy process is get it working. Get it working once, don't worry about automation. Get it up, tell someone else where the port is that you just started. Maybe write a bash script so that it might work the next time. but there wasn't really much of anything. So the advantages, which of course, as I make it sound pretty lousy in hindsight because it's hindsight, that there were obvious advantages to it. Very fast dev cycles. When you're in startup mode and someone tells you you need this feature that grabs, the past 2 years of some Twitter history and searches for a certain handle and it sticks that in another database, and we need it tomorrow, you don't really have time to do it well. So this is, build a prototype, ship it, and this system works great with that because, there is no system. You just get the prototype out. Yeah, deploys are instant. There's no deploy system. You just deploy it. So everything's great for basically like minute 0. It's fun. It's never boring. Every day is like 10 fires to put out. You have to run around figuring out how to get, it's pretty entertaining as long as you don't have real clients yelling at you yet. Bug fixes straight to prod because there is no dev. And yeah, I mean, part of it, what do we have? We have running in screen, you'd have to go in as a different user, sudo shown the screen's like state file over to your user so you could resume it. And then once you resume it, you could start making, like actually seeing if it was still running, starting it, like hit up enter if it's not running anymore. So pretty entertaining, plenty of disadvantages. There's no documentation. Every daemon requires like specialized domain knowledge. I mean, the disadvantages are pretty clear. Rollbacks aren't possible. You can pretty much only go forward if you screwed up. Like, what are you going to do? There was no monitoring. The monitoring was basically check if it's running once people complain that something's broken, and then start it if it doesn't work anymore. Very, very unstable. So as we sort of grew as a company, we came to this, or at least some of us came to this enlightenment of what if we were to deploy things to where we can find them later, which is pretty self-evident. So this first version was written in Python because the guy who wrote it was a Python developer, used Fabric. This is an example of what it looks like. Even if I get out of full screen, I can actually see it. I think Alt. Yes. I give up. So this is what it would look like. Basically, there was like Spy was a repository, was a deployment directory. Every service gets a directory. In each directory, there'll be a fab file, which tells Fabric what to do, and then a template for supervisor, which I haven't touched on yet, but that was the demonizing program we went with. Okay, this affects both of them. All right. Crazy JavaScript. Just made the arrows. So this is what a fab file would look like. It would, I mean, honestly, it worked very much like a bunch of imports where it would just like grab some stuff here, mutate it here, and then Fabric would know to run it. There were env name would be like the application name, in this case, the Twitter firehose, env.repos or what Git repos this thing relied on. The role defs would say like on dev, it lives on this host. On prod, it lives on this host, in this case, the same host, which is, as you can see, we're still pretty bad habits in terms of development. I think in this case, it was legitimate because we only had one key for the firehose, so we couldn't really have a dev unless we mocked it. This is what the supervisor template file looks like. I should probably describe a bit what supervisor does. Similar to run it in that it is a program that runs your daemons for you. If you are basically a shop like ours where we're not making software to ship to other clients, we have our own services. They're not it's not like we're not building syslog. We're building like a web server, and this will give its own CLI so you can monitor all the processes that you've spawned. It's not built to run your entire system, but it comes with a really nice CLI so that you can check the status of any running daemons. It'll tell you the uptime. It'll let you like tail the log files from it. It has a XML RPC built in, so you can check the status of anything. Where the other really nice features are restarts on exit, but built in, what do you call it, exponential back off. So if it exits immediately, like twice, it'll stop trying to restart it. And then if it exits, after a second, it'll wait a couple seconds, start it up again. And that's really nice to be able to introspect what all your daemons are doing and how they're running. So yeah, he decided to go with supervisor. You can see this in rudimentary. This is actually Python's built-in sort of sprintf replacement. The percent, you basically pass this string a hash and it will swap into keys. The S signifies the same as the sprintf pattern where it's a string here. env would get replaced with prod or dev depending on where you're deploying it. Python would expand to where the path is to Python. So yeah, this was a vast improvement. If you're, oh yeah, and this is what the Python code looked like in Fabric. Basically wrappers around SSH. So you do run, you could do like fab supervisor CTL, and that would call run supervisor CTL -C and then pass in command, which is coming from the command line. Everything's set up as tasks, sort of like a rake file or make file, that the tasks get defined as the commands. So yeah, it works pretty good. What was I saying? Oh yeah, auto restart true. You can see here restarts on exit. So yeah, we had a lot of success with supervisor. We still use it now. I would definitely recommend it. It's mature. I think it's like 10 years old at this point. Interestingly, when I was looking into bugs in supervisor from like 8 years ago, there's somebody doing what we ended up doing, which is like building out supervisor templates with template toolkit Perl. So it's been sort of crossover since then. So yeah, so the deploy process with this new system, this is what, when you would do like fab deploy prod, you go to like CD into the deployment / Twitter Firos directory, and then you do like fab a prod deploy. It would SSH the deploy server, sanity check a couple things, make sure supervisor D existed, create the subdirectory and opt SocialFlow env application or applications like Twitter. This would be like opt SocialFlow prod Twitter Firehose. Then it would git clone each repository. This is the deploy server being the production server. This is where you're deploying to. Go in there, SSH in, create an empty directory, clone all the repos, CD into each one, install all the dependencies into like virtual env or Perl 5, depending if it was a Perl or Python system. Render the supervisor template file, and then start supervisor D if it wasn't running, and call update. Update tells supervisor to reread its config and adjust any daemons who have, where their stuff has changed. I don't remember where the light switch is, but it's Nicole knows. So that's, yeah, another really neat thing with supervisor. If I sort of back up to what the thing looks like. Here. Yeah, so like you take your template, you edit command and add like Python-U for like unbuffered. When you call update, it'll detect that the command has changed here, and then call hup on the command, which hopefully you can edit the options for. We've just sort of realized that that's what it does, and like been very careful calling update, because you could definitely surprise yourself when everything exits, especially if the new version doesn't work. But yeah. Right. That was the deploy process, the demonizing mechanism. We sort of settled on supervisor. we ditched run it. We ditched any attempts to demonize our own stuff. Perl has like a lot of great libraries for writing like an int scripts and demonizing your own stuff. We basically didn't want to use any of it. We wanted to use, just leave everything. Anytime there's a foreground mode, just use foreground mode and then help supervisor do the demonizing. Standards, the logs were still anywhere. Supervisor D does grab your standard error and standard out and put them in separate files somewhere. I think the default is like the current directory. The code was in opt, which was pretty good. Wasn't in the home directory most of the time, except for the older deploys. The state files, and when I say state files, I mean like a PID file or anything that's like, since this process started, I need to store some state about like maybe the last ID I fetched or something. Maybe uptime or something like that. And the config would generally still be committed into version control. We wouldn't really do live edits as much because the first time someone else deploys over you and wipes it out, you sort of learn that's not the way to do things. So this comes a lot closer to what you achieve when you're like looking at Puppet and Chef. This is where it starts coming into play of just, I guess, the stick aspect of using like a framework to deploy stuff, where you don't do stuff on prod anymore because you will get screwed really quickly the next time someone deploys and it overwrites your changes. You basically learn the hard way that you should be doing the stuff, committing your code and deploying it. And in a pinch, you could emergency hotfix it on prod, but then you're pretty sure to edit it on in the code so that the next time it gets deployed, it'll. By the way, has anybody had any questions so far? The deploy process looked sort of like this. It'd be like just basically read args as ops. You basically say like arg1 is the environment, arg0 is the environment, arg1 is the command. You put it in quotes if it needed, which is, obviously to fool the shell into having it as one thing. So yeah, fab prod deploy would deploy prod, fab prod supervisor CTL, restart all. Fabric would read the command as the colon and the second part as the parameters. I think it probably works like comma separated and stuff. It's pretty neat in theory. This was the advantages. Right, daemons will be restarted as they exit. The CLI is really good. It's automated. It's not a manual process. Somewhat documented. You could go to that deployment directory and read out where the applications were. There were still special cases. I mean, to be honest, there's still cases where we don't use the newer framework. Generally, the special cases will be stuff where, like Nginx, Postgres, anything that is not our software, pretty much. Or, though we do run Redis, but we build it. So I guess the general rule is anytime it's a system package or it requires special permissions that we do not have not built into the deploy system, we'll use the system. We'll basically have a separate path to do it. With the web server, you don't want to run things as a privileged user. You want to run it as data or nobody or whatever. So you want to. But with this thing, there were more special cases. Like Redis was always demonized, so like that would be done one way. It would. I think I have. That's advantages, disadvantages. Right, disadvantage. There were a lot of exceptions that wouldn't fit the model. Redis, I think we were still demonizing, so that would like sometimes we'd set it to foreground, other times they were in the background. I sort of hammered our Perl daemons into this, but it did not work so well. I mean, it worked, but it wasn't great. Fabric really doesn't like environment variables, as far as I can tell. Python in general is not like super heavy or on environment variables. I guess they're not so pretty, but so like you end up sort of prepending everything manually, like building out the string. I'm sure there's probably a better way to do it. This was also a couple of years ago, so it might have advanced since then. Rollbacks were hard or impossible. This is more the way we were doing it than the actual system itself, but you go to the production server, the version that's deployed, the new version gets dropped right on top of it. It goes in, it checks everything out. Pretty much everything was pointed to like master, the master branch in Git. So yeah, it was not rolling back. If you are just deploying straight to master, is pretty much, I don't know, I guess you can check out the commit that you remember as being working, but even the even worse case is that your code is not breaking it. Your external code, like a external dependency that is downloading from, I forget what the hell you call the Python one, but that you install via pip or the Perl one from CPAN. If that's broken, then you're really screwed because you'd have to install like a specific version, like pip install equals specific version. If that thing's gone, then you're just totally screwed. So yeah, the deploys are very risky because they're in place. There's no backing out. There was nothing built in for managing config, logs, or state, or data. Like when I say data, I would mean like where you put your database. If you're Redis, where your like Redis database goes. If you got like SQLite database, where you put that. These are all, I mean, you know, this just, I addressed this a little more later, but this is generally what what people who know this stuff know, but what I sort of learned later of the stuff that you have to be concerned with application deployment is there's the software, there's the config, there's the logs, there's the state data, and there's the data itself. There's standards for all these things. There's a lot of different standards, but Linux will have their log, their run, their lib, opts for external software that you don't want to put in other places. So yeah, and then the last disadvantage, which really drove me nuts and sort of led us to rebuild, to sort of scrap this and start new. The fabric bugs, the deploy was unstable, it would crash often. Really sucked because I didn't really have any interest in debugging fabric. It has a large community, so anytime you have a problem and nobody else does, it's basically not a problem. They'll generally say like, it's a bug in some other software. And Fabric specifically had bugs having to do with SUD. So when we go to demonize the supervisor, half the time it would like break in the middle. We didn't know if it worked or not. So there was a lot of manual intervention. And at some point, we just figured, I can't say it here, but yeah, at some point we just figured it would be easier to replace it. So why replace it? This was, yeah, another huge disadvantage. Python, this would be a reason to keep it. Python has plenty of OS manipulating functions, temp files, path checking, dir exists, dir doesn't exist, create this, CD to that. So it'd be like a perfectly reasonable solution for deploying applications, except Fabric is not really, you're not running the Python code on the deploy server. What you are is running a bunch of commands over SSH. So you're pretty much wrapping like shell scripts. Your run will be a command where it's, it's doing SSH as this user and then piping this to the shell. So when you're like, oh, I need something to check if a path exists, like os.path that exists. You can't use that unless someone wrote a special function, which is basically a shell function wrapped in Fabric for you to use, which is really, really annoying when you actually start needing to do more than very trivial things. So yeah, at some point, we just figured it would be easier to do in Perl. Months later, it's clear that wasn't as easy as, this was my first estimate of how long this would take to build, and it didn't really work out that way, but now we got it. So these were sort of the overall goals in rebuilding. We wanted it to be self-documenting. Self-documenting is usually sort of a joke, and like I don't write comments because just read the code. But I, wanted it as an actual goal where the API described, not only ran, I guess you'd call it data-driven. It not only describes the application, but runs it as well. Versioned. This was important because when you're rapidly deploying out of Git, branch master does not mean the same thing as it meant yesterday. So I wanted everything to be, when you deploy version 1.1, it gets tarred up. That is version 1.1 forever, regardless of what went in it. I mean, you could generate a bunch of random data and type it into a build file, but that 1.1 will be the same because it's the same file. Standardizing the paths and extensible, because that's, I kind of hit the wall trying to build on top of Fabric. So I wanted something that we could sort of add whatever features we need to do quickly and easily. And ops friendly, we sort of built this hand in hand with our sysadmin on his recommendations. I pretty much deferred to him for everything in terms of like how things should work. And whenever it was a question of like, it's easier to do it this way, but it's more secure, better, more reliable the other way, we would always go the more reliable way. Because to the end user, you're just, at the end of the day, the deploy process is still automated. So just put in the work to get the framework to do it properly. And it's really the extra work to get it to be right was definitely worth it. So yeah, ops friendly, sort of the last two sort of refer to that, least privilege. The original, the previous system, everything goes to the server where it's getting deployed, where it's deploying. It checks everything out in Git. It installs all the dependencies. That means that server has to have Git. It has to have everything needed to build the software, as well as everything that needs to run it. And it needed to have a user privileged enough to get to GitHub or wherever you're hosting your code and download it, which, I mean, we would forward our keys generally using Fabric. You could do like SSH forwarding. So that wasn't that big a deal, but ideally we would move onto a system where you wouldn't necessarily have internet access on the production server. So we wanted a system that did not require super open access to everything. So you could deploy to a server that had like no access whatsoever, except like an incoming SSH port. That sort of ties into least privilege. Yeah, we didn't want necessarily Git and build essential and everything required to build everything on every machine. What's the other thing? Yeah, I mean, typically we'll have like libgif, like dev on the build box, and then you just need libgif on the production machine. So that's sort of what went into the design spec. So yeah, we built SocialFlow deploy. SocialFlow deploy, it's our deploy system. I would love to open source it. I'm not sure anybody's interested, but hopefully people are. It is the one of the main things keeping me from like open sourcing it immediately is that just as I built it, and as we built it, as I opened up a bit, there's things very specific to our workflow which we found to be best practices. So I kind of wanted to build that stuff first before open sourcing it, but there's a couple things that are very Amazon specific. Actually, the first version was less Amazon specific. It would build the stuff and build it on your machine and then copy it to the production machine. So your server with the build box, and then it relied on consistency where if the production machine was like Debian Wheezy 64-bit, your server should be, the build box needs to be Debian Wheezy 64-bit. And we accomplished that with virtual machines for the most part. So that was a little more, less SocialFlow specific. But then we sort of added in the step to actually have a build box and then upload it to S3 and download it from S3. So that part we need to get abstracted out. Any questions?
This isn't available
Hmm?
now. This isn't available now.
It is not. I mean, I could pretty much upload it any day, and then I would probably just need to audit the code, make sure there's nothing stupid in there. Well, I'll leave the stupid stuff in, but I'll leave the like security stupid stuff out. But yeah, I guess I'll put up a link for tomorrow. I'll get on GitHub. And then to CPAN once it's got tests.
How do you interface with S3? Is it just like SSH as though we're its own machine, or how does that?
You mean in general?
Yes, in general.
Yeah, no, S3, you have your auth tokens and you construct you basically interact with it over HTTP. So you can put a file, you can get a file, you can do a head request, and you just basically generate the headers based on your keys and the time and the like content that you're requesting.
So what do you use it for? What is your application use it for?
Our application uses it to store the built versions. So we'll build the software and then we'll upload it to S3 as like Debian, Wheezy, Twitter Firehose v1.5.tar. And then that is the source. If it finds it there, then that's the build for it.
Is it executed on AWS?
No, it's just stored. It's it's just no. S3 is just it's executed on AWS. Amazon, we have like Amazon machines where it gets deployed to, but S3, we just use for file storage.
So it's like an EC2 instance, and you're just using the file storage and pushing it to the EC2.
S3 is not an EC2 instance.
No. What I'm saying is that
Yeah,
you're
exactly.
storing the tar file in S, but you push into a virtual machine like an EC2
Yes.
instance, or
Yeah, everything runs on EC2. It would work, I guess, if you wanted to, it doesn't really care if it's EC2 or not. You could just give it like a host name and it'll go there, as long as you have S3 access.
Is there like some kind of script inside the hardware magic stuff, or just unwind and go?
It's just unwinding. I mean, I got plenty of that sort of covered in the next slides. But you have a question?
Yeah, I just wanted to know if you looked at Rex at all.
Yeah, I
If there were
did
any
look at
disadvantages or advantages.
Yeah, it looks cool. I didn't build on top of it. I don't remember why. I think mainly because I'll talk about it later, the technologies that it's built on. We actually sponsored Object Remote, which it's built heavily on, which probably impacted the reason. SocialFlow Deploy is the name of the project. It's a crappy name, but I'll figure out a better name and delete the SocialFlow part of it so that it's more general. I'm not a big fan of the Java style, I love NYT Prof, but every time I see it. So DA standards. If you're an op or if you're anybody and you want to find where stuff is, it's great to have some standards for where to find things. We put the code in op SocialFlow env app version. The state files go into var run. Basically, everything was SocialFlow /env/ the name of the application. So we have a user that has access to those directories, and then it'll create the subdirectories. So the logs go into var log. We drop a script in initd to be able to start and stop the whole supervisor process or pull the status. It's worth noting that this is somewhat of a standard in terms of SocialFlow /something else. I think it's a little more standard and probably would have been smarter to do it all at the root opt directory. So opt/SocialFlow/ like app/env/ app-env-version, because we ran into some issues later where if you need, especially with Nginx, if you need like www data to be able to have read and execute on something like in a nested directory, you need to then give it read and execute on the whole hierarchy. So that's why I would not have, starting again, I would not do it this way. I would do it opt SocialFlow and then like one block. And the other non-standard thing is we, in varlog SocialFlow, we did env-app instead of / because we could not figure out how to get syslog to do what we wanted. We figured like, whatever, it's obvious. Once you, it's not that complicated.
It's also similar. It's also similar. So everything you change the app.
Yeah, we could do that.
As you go along.
That's true. So yeah, this is I might have to zoom out. This is what this thing is automating, and we pretty much came up with this before building it. All right, so SSH is to the deploy server and the build server and holds both those connections in memory. If the version is deployed already, exit, it's a no-op. Check if the version is built already and already exists in S3. So it basically just checks the web and says, is like Twitter Firehose 1.3 already built? If so, download it and untar it. And then create subdirectories if it needs them. And then if there is no tar file found on S3, the build process, it goes to the build box, clones all the repositories if there are repositories to clone. This step was very specific. There's been a lot of back and forth in various languages on how to stabilize your software that relies on the cloud, CPAN or Ruby Gems or PyPot, the Python one is. So how do you get that to be stable? Sometimes we've had systems that rebuilt everything from CPAN every time, fresh, which is not great because you're seeing everything new for the first time. Now there's like Carton, which does stuff. There's Stratapan, which I think lets you specify specific versions. I sort of keyed on this idea of what we already do in development, which is install on top of the stuff that already works. So like in development, you do your work, you do install deps to install. So basically, if you need a new version of whatever Redis PM, you bump the version of the make file and do install deps, because in this case we're installing out of Git, so it'll, which I think I say down here, it'll cd into the repository and do like cpanm install deps dot. So basically, if you need a new version, you bump the version. Everything else remains the exact same version as the previous version, which hopefully worked. So there's no nasty surprises usually. And because we actually have a development process, once we'll have a dev box, it'll get tested. So if there is a nasty surprise, which they're not super rare, but there's been I can't remember specific times that we've broken stuff with newer versions. It hasn't happened that much because we usually find it first in development and fix it before we even do the deploy. Because the step before this is like development on this stuff happens still, on our dev machines and locally and stuff. We'll get it working there, set up the make file, and then generally that's close enough to the deployment so that's not like a giant leap. But there have been times where we get like a broken version of date time that's fixed like a minute after we downloaded this. Anyway, so that's sort of what we do for stability. on that front is copy the previous working version and then build on top of that if it needs a new version. It installs, you can specify, you don't have to, I mean, we have an internal cpan, so you do not have to build stuff straight out of Git. You can specify that this thing just needs to, like SocialFlow : Twitter : consumer, and then that's the only thing it needs, and then it'll set up its Perl 5 bin and just run it straight out of that. So yeah, it builds it, tars it, uploads it to S3, and then on the deploy server, just untars it, symlinks it to current, which is in, I didn't describe as much, but basically the build box does not have an env in its path. It just has ops, SocialFlow, Twitter Firehose, and then the deployed, the production box will have the ops, SocialFlow prod, Twitter Firehose, and then they'll CD there, untar it, symlink current to the version that you just untarred, and call update on supervisor. Supervisor checks to see if the config is different. We have another command to restart the processes that you can do from the command line, but that's not in the deploy because it would probably be a bad idea to roll it up. You could do it in one command, but I didn't want to do that as like the default -- deploy. Let's see. But yeah, this is sort of let's exit this window. This bigger. Maybe it's an iframe. Maybe it's not as big as it goes. Huh. Anyway, this is like a typical service. There is these are the layers basically. There's a config for the application. There's an application level config. There is an environment level config. There's config files, which will get synced over. These are like required config. This all lives in a specific Git repository for our application's deployment. You can see, prod pretty much mirrors dev here. It's got similar files. There's some put encrypted files in there. These aren't in the Git repositories or symlinked to an external spot. This is like common for dev and prod. There is a supervisor, except now I'm using Perl templating instead of Python templating. There's a version YAML file. It is you just execute it on the command line like this. You basically, I wanted it to be path based. I thought that was pretty neat to like force everything into paths so that you do like /prod, it knows that you can pretty much read everything inside the slashes and know this is the environment is prod, the application is resolver. -- deploy is pretty much like a macro which will build it, deploy it. You can pass things straight into exec to just run it on the remote side. rsync share will copy over the config stuff, and deploy pretty much implies all the things for deploy. Talk about the features. Yeah, rollbacks, super easy. I already sort of mentioned this, but you can do it from the deploy side in terms of like just edit the version that you want deployed, change it from 1.5 to 1.4 and hit deploy again. Or if you're on the box itself, just change the symlink to current to the version you want and then restart it. The configs, we use templated config, which is really nice. It's TT template toolkit syntax from using text xslate because you can do very strict templating so that if env is not defined, it will be a fatal error, where template toolkit, getting that to work properly is very, very hard or impossible. And so this gets replaced with like prod or dev or QA or something. this will swap in the Etsy, SocialFlow, Prod, Twitter Firehose. So you could, and then this is like, it is the exact same variable. There's also like application led path, application run path. And I'm trying to think if there's, yeah, that's the template config. So this is actually, you know, this, you can pretty much any config files that your software needs, you put it there. You can put the variables and it will get rendered when it syncs it over and swapped in with the variables. So this is sort of what it looks like inside the YAML files. Oh, this is another feature, the network requirement testing. It's pretty common to not have any idea what the network requirements are on a thing if you're not careful. So this will actually explicitly test that the box you're deploying to can connect to these things. And down here, you could see like a port.sfwebredis.sfwebredis. There's actually a port.yaml file where we declare all the ports that we have. That was another conversation with sysadmin. It was like, you know, you shouldn't use just a random port. You should pick a port, like declare that to that service. It really bites you when you use the random port and then you want to migrate a service and all of a sudden you can't put two things on one box now because they have clashing ports. You have to change the code. So we found it very useful to declare all the ports. And also, you know, it helps in terms of systems once you're on the box, figuring out what's where. So yeah, basically put that in the templating so that you could pre-declare the ports and this will go in and check that it connects to it. Some of them where they are already existing in, I forget the file that lists all the ports of like existing services, but yeah, here I just put the string PostgreSQL, and that will work on pretty much any most things that expect a port and then proxy down to like the lower level OS functions. This doesn't work with a dash, I found. Like if it was PostgreSQL, that wouldn't work. Yeah, here's some other nice features. PGP encrypted creds. We use PGP everywhere. So if you deploy and there's an encrypted credential, it'll say like, decrypt your file. It's pretty much a shelling out to PGP decrypt. And that'll be just a YAML file with the password to the actual encrypted credential. And so basically, before we just sort of had a bunch of random passwords to randomly password files. This way, you enter it once, it holds the encrypted file in RAM, and yeah, it's pretty nice. Auto-generated Nagios checks. I'm not going to talk too much about it, but because the system's so introspectable in terms of the config, everything's in a YAML, and everything's readable. You can see we were able to generate really easily some auto checks of like, make sure this thing is running. If it exits, send out an alert that it's down, and built some performance graphs on top of that because supervisors, XML RPC will tell you like, this is the PID, this is the uptime. No, I think I just read the PID out of it and then you do like process tree. There's like a process tree module we use to get the memory use, the uptime, and then graph all that. It's just like the fact that it's extensible. We added like just run an arbitrary script during a build phase. If you have other stuff that goes in your build, write a script and it'll execute it. Put in things like apt requires, which I think we're probably gonna remove and just make it that it finds it in its path. That'll just check to see if certain things are installed. C header to check if certain C headers are installed. I think we use that for libc and Q to make sure that's installed. I think, yeah, so I can show you a little bit. Let's see. I'm going to zoom in 1 second. tell it's like overscanning. So what's a good one? All right, so this is the general structure. Can you guys see back there? Or sort of bigger?
Yeah.
Cool. I could probably make it one bigger. Crank it to 11. There we go, that's good. All right, so yeah, like I sort of mentioned before, there's like some stuff, hit the slash there. There's some general application config stuff in here. What user you're installing as, where your build box is located, your S3 credentials, that lives in the root. So basically everything is path-based. The stuff that's, I tried to name everything config.yaml, so it's predictable. Everything that's top-level config lives in SFDeploy application. Application-specific config, kind of like application site stream, and then there's config.yaml. That's the application config. This was so I could introduce breaking changes, and it will basically exit and say you need to upgrade your version of SocialFlow. Because what we found with chucking an arbitrary hash at a piece of software is it's not so predictable. It's great for, this is sort of what I meant with this self-documenting, is it's readable. You can pretty much look at it and be like, oh, okay, I get it. This thing is a config. It is templated. The language is Python. These are the Git repositories. These are the network connections it requires. This gets passed into the supervisor template. And all that stuff, when you look at the environment config, is, yeah, this is the host it's deployed on. This is the version to deploy. This is where this is some files to sync. This is not templated, but it is encrypted. So yeah, we just tried to go with a very expressive API. You declare the network connection is like this network connection is defined as these connections. Briefly, yeah, this is what the version YAML looks like. You bump the version, you tell it what Git repositories, if it is a Git repository. It's got a bit of its own language, not very complicated, but basically tag will tell it it's a Git tag. Branch will tell it it's a Git branch. Yeah, you can see branch master. Typically, I like to freeze things that are, generally there'll be like a main repository and then there'll be other stuff which has dependencies. So I'll freeze the other stuff at a tag, and then the main one, I'll just leave it master so I don't have to keep tagging every time it changes. Quickly, what's the one that doesn't really have? What is the yeah, so this is basically what it looks like when there is no Git repositories. You just specify this syntax, CPAM-I supports it. It's, I forget what defines this syntax. There's like a module which describes what it is, but at is like equals this specific version. You can do like greater than or equal to. But yeah, this basically says version 56. I just basically added a 1 to it because we didn't start with this. Normally I would do 56, 56. This basically says like install CPAN SocialFlow reporting daemon. And then you can see, I don't even think this has a specific template. It just sort of runs it out of, I think we have the generic service template for ones that we don't even need, like a specialized supervisor template. I'll just say like, this is the, I think that's, yeah. Oh yeah, Perl dependencies. This is like install these things from CPAN. Yeah, and then supervisor template. If there's like a shared template, you can specify it here. So I think it's actually running a little long. I thought this might take 5 minutes. Yeah, I think I covered all these. Application config, environment config, version config, shared config files, import config. And yeah, before I just go to the tech stack real quick, I thought, I think even whether, I think the software works really well for us. More importantly, I think is the standards that we decided to follow, and having standards, using them, having like consistency across your system, across your deploy system is more important than the specific framework you choose to use. I like ours a lot because we built it, but that doesn't make it better than any other system. As long as you stick with it and make sure everything uses it and are consistent, you gain a lot. We've definitely seen what you get out of putting in the work, front loading all the work to get everything consistent. We're now able, there is no more like running around asking like, who wrote this, how does this run, where is this going, where is this, what does this actually do? You can pretty much say, like what does this thing do? You can check out the supervisor template, see exactly what commands are part of that particular deploy, go into the version, figure out exactly what code it uses. So you can pretty much follow everything back to the source. So that was really the goal of designing it. And just really briefly, the tech stack, why I like SocialFlow deploy specifically. It's built in Perl. It is built to be able to use almost any CPAN or Core OS. Like Core OS is probably trademark. Like things that are in Perl core, like CP or Unlink. So I mean, I'm just calling back to what I was saying about Fabric. You can't use any of that stuff with SocialFlow deploy. It's actually shipping the program to the remote side using basically fat packing, where it will copy. It will look at your entire. It looks at the SocialFlow deploy code. Fat packs all the dependencies into a single file where it will follow the dependency chain, build out one giant Perl script with all the library files in it, ship it to the remote server, and execute it. So you can pretty much just throw in whatever modules that you need to do what you want. We use IO all a lot, which is basically proxies to a lot of file utilities. CWD for like changing directories in a certain scope, file copy for like, we might use rcopy also to like recursively copy things. Very simple, I mean, very, very useful things. IPC run, IPC system simple, both do similar things, which is to like run things or capture them. IPC system simple is great for quick things, but it'll block. Where IPC run, you can sort of stream standard error back. So if you're like installing a whole bunch of stuff, you can run something and then get the standard error streamed back to you or standard out. Yeah, so we built everything on top of Object Remote. It's sort of Matt Trout's brainchild. I linked to his YouTube talk where he talks more about it. It looks like this, which is really very cool. How do I make it smaller? That's crazy. As these get bigger, this gets smaller. I know there was actually like a freaking. Basically, you inside your code, you can call Object Remote Connect to this user at this host. It'll form an SSH connection to that thing, and then you could just do like my class new on or whatever on the connection, and then you have an object that's actually running in a remote Perl interpreter. So you can pretty much write your code as if you're executing it anywhere, in theory, and then ship it to the remote side with it's just. You basically just call new : on. And yeah, Matt tried to explain in the YouTube talk, but he's basically abusing the end thing because you can SSH in pipe in a Perl program, it'll hit end, and then it'll yield you standard in, basically. And then he has like, there's like hooks into the ink, into @ink, so when you do use whatever, like use IO all, it'll say, I don't have IO all, and that'll ping your server will ship it over to the remote thing. Very, very cool, works most of the time. It's still very experimental, but since we sort of like working close enough with them to be like, this is a major bug, and it gets fixed. And so yeah, I mean, most of this deploy system is built very much on top of it. It's been super reliable. I ran into some bugs on Perl 520, but I think that's on my end. No, caveat, no access. I made it very small. Yeah, he talks about in the talk how like PAR is crazy and tries to bundle excess. His caveat is like no excess. I think that's actually when I contributed the golden module for like test no excess was for this because I kept breaking everything because it would, yeah. The one way to get around that is to pre-ship your modules because basically it will only ship things it doesn't find. So if you're deploying to the same servers and you really want an excess module, you can just go, what I ended up doing is having a separate deploy that I call like SF deploy Perl 5. And then I shipped that to the remote server, and that you could do whatever, just a tar file. And then in the environment variables, I said use that as your local lib. So I can, install whatever I want to that. So yeah, that's 2 slides combined, but it's briefly, yeah, I already mentioned text xlate, but we also use moo, which is like it's kind of like Moose, yeah. MooX options is great if you are looking for yet another CLI processing module. YAML, as you saw before, we use it everywhere. It's easy to read. It's a pain in the ass, but when you get it right, it works really well. Yeah.
Which YAML module?
That's a good question.
Are you using YAML or YAML?
I am not using YAML type. I'm using YAML. I tried using YAML XS, and it worked most of the time. And sometimes it was different with very large files. So yeah, I think we're just using YAML. Definitely not, but we're not shipping YAML over the wire because all the stuff in YAML is config. So yeah, I mean, that's one of the things with Object Remote. There's definitely, you learn which things fat pack really well, which ones work really well over the wire and which things don't. And luckily, when you're doing like OS manipulation, there's not like an enormous set of things you really need to do. So pretty much once you have your tool chain of modules that work really well over the wire, you just stick to that. And that was sort of that slide I had listed before with file copy, file path. I think path class works pretty good. But yeah, that's pretty much it. Any questions? And yeah, I'll put up a link once I get it. I'll try to get it up on. I'll get up on GitHub before the end of the week. No, I'll update the meetup.
Hey.